Hola, ¿cómo estás? Matemáticas ocho. That's all I got for you. We are doing chapter 4, section 6 here, our next exponent property, and you are going to like this exponent property. I think this will be relatively quick. I'm going to review dividing just a little bit, and I'm going to go on to our one new property, which you will enjoy, and we will be ready to move on here. So chapter 4, right? Chapter 4, section 6. Let's get after it. The first thing I want to look at here is I want to look at division one more time. So first, I'm going to look at the way I asked you to do this. And the way I asked you to do this was take the coefficients and write them as their own fraction, and then each variable as its own fraction. So we would have the x's together, we would have the y's together, and we would have the z's be together. All right? And I'm going to reduce each one of these separately. Then after I reduce it, I will multiply them back together, kind of. So over here, let me set up my answer blank. Oops. All right, so I start with the 6/8, right? 6 over 8 can be reduced. If you can't do it mentally, you can do it on your calculator. 6 over 8 reduces to 3/4. So far, I have 3 over 4. And I don't think I want to write this out every time, but let me go over again how to do this. X squared is really x times x. X to the 5th on the bottom is really 5 x's multiplied together. And now you can reduce the x's because when you have the same factor on the top and on the bottom, they cancel each other out. So because I have an x on top and an x on the bottom, it cancels out. I have another x on top and another x on the bottom. It cancels out. And then I cannot cancel out any more of them because I'm out of x's on top. So I end up with this x times x times x on the bottom, better known as x to the 3rd power is still left over on the bottom when I reduce the x's, right? And you do the same thing for each variable. I have 3 y's on top, but I have just 1 y on, right? That's a y to the 1st. I have 1 on the bottom. So if I canceled out the y's, I would run out after canceling out 1 y on the bottom. And there would still be 2 y's left over on top. Therefore, 2 y's on top. And last up, I got the z's. Should I do it one more time? What the heck? I've got 5 z's on top, right? Z to the 5th. And I've got 4 of them on the bottom. So when I go to cancel out the z's, I can cancel out one of them. A second one goes away. A third one goes away. A fourth one goes away. And now I'm out of them on the bottom. But of course, I still have 1 z left over on top. So 1 z in the answer. And I'm now done reducing this fraction, right? This is my final result. Now, I would like you to do that without having to write them out and cross them out. I would like you to just look at the fact, that there are 3 y's on top and 1 y on the bottom, and just know that when you cancel them out, you're going to run out on the bottom after 1, which will leave you with 2 on top still, right? That is a pretty easy way to reduce fractions, or divide, if you will. But that is not the official rule for exponents. I just think it's the easiest way to think about it. But here's the official rule. We're going to do this same problem one more time. but we are going to use the actual exponent rule for dividing. And here's what it is. Notice you still simplify the coefficients, right? Just like when you're multiplying, you multiply the coefficients. When you're dividing, you divide the coefficients. They get whatever operation you're doing, you do it to the coefficients. But the exponents, when terms are being divided, you subtract the exponents that are on, I always forget to say that, exponents that are on the same base. And you always do the top minus the bottom. So sometimes when you do that, you're going to get a negative answer, and sometimes you're going to get a positive answer. Here's what you do. You always want a positive exponent in your answer. So if the result is positive when you subtract, put your result on top. But if the result is negative when you subtract, put your result on the bottom. But notice, make it positive when you put it there. So this is what that might look like if we were doing the same problem, right? First, you would take the coefficients and you would reduce them as always. 6 over 8 reduces to 3/4. Now the exponents get subtracted. So for the x's, you would be subtracting the 2 and the 5. 2 minus 5. For the y's, you would be subtracting 3 minus 1. And for the z's, you would be subtracting 5 minus 4. This is the official exponent rule. So when you go to your answer, of course, you still have the 3/4. Now for the x's, you have x to the 2 minus 5, that's negative 3. Since it's negative, it goes on the bottom of your answer, but it turns positive. The negative tells you, put it on the bottom. The y's, you would subtract 3 minus 1. That would be y squared. And because it's positive, it goes on top. When you subtract and get a positive result, it goes on top. When you subtract and get a negative result, it goes on the bottom. And your z would be to the first power. And since that's positive, it goes on top. And that's your result. Notice that this result is the same as it was back here. Same answer. We just did it the official way now. You know that when you're dividing, you subtract the exponents. That might come in handy on some problems. You might find that easier on some problems. All right, so that's my review of dividing. We have one more rule today, and today's rule is the zero exponent. Now here's the thing, the zero exponent is tricky. He's a tricky guy. Most people think that if I have something to the 0 power, it will equal 0. Really? Well, it does not actually. And you could try that in your calculator. I think we should look at that, by the way. So in your calculator, you could type in 5 to the 0. I want to show you how to do the to the button, I call it. This button right here next to my finger, we got that? Yep, the little up arrow. That little up arrow is the to the. When I hit it, see right now it just says 5. But when I hit the to the button, now I can put an exponent in there. And if I put in a 0, I wonder what it'll be. Well, I'm about to show you. Here we go. To show you, I want to look at a couple patterns. The two patterns we're going to look at is exponents on 2 and exponents on 3. So look at the pattern I have going here, right? On this side of the problem, I am reducing the exponent by 1 each time, right? It's at 2 to the 4th, then it's 2 to the 3rd, then it's 2 to the 2nd. I'm reducing the exponent by 1 each time. So what happens over here when I reduce the exponent by 1 each time? Well, it gets cut in half, right? 2 to the 4th power is 16, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. And 2 to the 3rd is 8. 2 times 2 is 4, times 2 is 8. I claim over here what we're actually doing is we're dividing by 2 each time. Right? From here to here, I'm dividing by 2, which kind of makes sense because I'm losing one of the 2's each time. I went from 4 2's down to 3 2's. Now, what's 2 to the 2nd? Well, 2 to the 2nd is 4, right? Again, I divided by 2. And what's 2 to the 1st power equal? Well, it equals 2, right? Again, 4 divided by 2 is 2. So if I keep this pattern going, what does 2 to the 0 equal? If I divide by 2, 2 divided by 2, what do I get? I get 1. And that's actually what 2 to the 0 is. Or, if you look at my calculator again, I have 5 to the 0, and when I hit enter, that's right, it's 1. Let me show you that this would work with the 3's also. I'll do this relatively quickly. So over on the 3's, 3 to the 4th is 3 times 3 times 3 times 3, which is 81. And then to go from here to here, I really am dividing by 3, right? If I divide by 3, one of the 3's cancels out, and I have 3 times 3 times 3, which is 27. And when I divide by 3 again, I get 3 squared is 9. And when I reduce the exponent to 1, I divide by 3 again, and I get 3 to the 1st is 3. And what happens when I divide by 3? Again, to go down to 0, 3 divided by 3 is 1. Ooh, that's 1, and that's 1. By the way, this really gets interesting if you do it again. Ooh, what if I go down again? Now what? Well, that's for another day. But what we have discovered here is that it seems like no matter what I do, when I have a 0 exponent, the answer is 1. And if you flip to the back, that is the 0 exponent property. Any non-zero number to a power of 0 is 1. The only time that's not true is if you have 0 to the 0. It's got to be a non-zero number. So 5 to the 0, 1. X to the 0, 1. This is the one that tricks most people. 3x to the 0. Because most people just want to say 1. But look, 3x to the 0 is really 3 times x to the 0. Right? Those are being multiplied together. So really this is 3 times 1, which is 3. The x to the 0 is equal to 1, but the whole thing is equal to 3. And for just a couple minutes, let me do some practice with some problems that have an x to the 0 in them, and we'll be done. So I'm going to do this two different ways. One way I'm going to do it is by the multiplying method. When you multiply the coefficients, but you add the exponents. Well, what is 2 plus 0? That's 2, right? So this is 12x to the second. Right, that's true. Multiply the coefficients, I get 12. Add the exponents, I get x to the second. Or, what if I use the 0 rule? All right, then this would be 3x squared times 4, but this x to the 0 is equal to 1. So instead of 4 times x to the 0, it's 4 times 1. And that means this is 3x squared times 4, because 4 times 1 is 4. And 3x squared times 4 is 12x squared. It doesn't matter which way you do it, as long as you follow the properties, same answer. How about this example in the middle? Well, this thing in the middle, this whole thing in parentheses, is to the 0 power. That wasn't a very good arrow. Oh well. So that means this whole thing is equal to 1. And my answer is 1 over 3x squared. And then last up, should we do this how we've been doing, a power on a parenthesis? Should we apply this 0 to each thing? Sure. This would be 2 to the 0, x to the third to the 0, y to the fifth to the 0. And we now know that 2 to the 0 is 1. And when you multiply those exponents together, because when you have an exponent to an exponent, you multiply them together, that'd be 3 times 0, this would be x to the 0. And when you multiply those together, you also get 0. This would be y to the 0. But wait a minute. That means this is 1 times 1 times 1, which is 1. You know, it'd be far easier if you just said this whole thing is to the 0 power. And if the whole thing is to the 0 power, that means the whole thing equals 1. All right, that's the 0 exponent rule. Basically, anything to the 0 power is 1. You are ready. I will see you guys next week, I guess.